TV. Hey, this is Geometry 1-7. This is what we're doing. We're on page 26 of your notes, and we're doing section 1-7. The things we're going to be covering are midpoint, distance, and Pythagorean theorem. All those are going to be formulas that you've used before, okay? Keeping in mind what we're doing, today we're going to start out with midpoint formula, one dimension. Okay, one dimension midpoint, just on a number line. You've done it before. You have two endpoints, and to find the midpoint, we're on page 26, I think it is. To find the endpoint, you just add the two together because you're taking the average of 2 points. Okay, so I have two endpoints, take the average. That's all I'm doing, -4 and 9. That's what I'm doing. So -4 plus 9 is 5. Cutting it in half, I get myself a 2.5. That's all I did. I took the average of two numbers. Now, you guys recall seeing this before? Okay, now we're going to do something just like it with two dimensions, except I've got to do the average of the x's and then the average of the y's. The x's are the horizontal average, the y's are your vertical average. And where those averages come together is going to be the midpoint of whatever point we're at. So let's look at an example of it. Okay, so like I said, the coordinates of the midpoint are the average of the x coordinates and the average of the y coordinates. When I'm doing this, the average of the x's, now remember, our x coordinates are right here. And if I take my endpoints of my x coordinates, because they're the horizontal coordinates, and I divide them by 2, and I take the endpoints of my y coordinates, because they're the vertical coordinates, and I divide by 2, I'm able to find my midpoint. My x coordinates are first, my y coordinates are second. The hardest part of this is that people don't recognize that x sub 1, the x sub 2, they're actually from different points. The x value is the first value in your coordinate pair. The y value is the second as you working with that coordinate pair. So often when we do this is that people will take this as the x coordinate pair, and it's not, and they'll take this as the y coordinate pair. Well, you got to keep in mind, if I wrote these differently, it would be a completely different answer, you know, if you did it that way. Make sure you recognize that it's always an x, y coordinate pair combination. So when we're using midpoint, or even if we're doing distance formula, we are taking the x from the first point, the x from the second point, and we're adding them together, dividing by 2. We take the y from the first point, the y from the second point, add them together, divide by 2. Those subscripts are there to tell you, the user of the formula, that that formula requires two different points. Okay, does that make sense? So as we go on, the really cool thing about midpoint is that I've got 2 points. I'm going to find the average of the x's, the average of the y's, and that's going to be my midpoint between whatever 2 points it is on the coordinate plane. So I got 2 plus 7 plus 14, excuse me, 2 plus 14, which is going to be 16, divided by 2. So my midpoint of the x's is 8. Now, my midpoint of my y, 7 plus 20 is 27, divided by 2 is 13.5. So I got 8 for my x's. 8's my midpoint for my x's. Well, that was cool. Let's not do that ever again. And my midpoint for my y's is going to be 13.5, 27 divided by 2. Are there any follow-ups with that? Okay, give it a try. Go on your own. Okay, remember, x's are first, y's second. Add the x's, divide by 2, add the y's, divide by 2. As you're stepping through, be careful. The most likely thing you're going to do is mess up on notation. And once you write down something wrong, you'll just keep working with it. Just double check it before you do, okay? So now we get going here. I have an answer. Really, it's here. Okay, or if it's there, all right, killed it. So now I've got -5 plus 12, which is 7, divided by 2. I got 7 plus -17, which is -10, divided by 2. To finish it off, I got 3.5 and -5. So that's my midpoint. Sometimes we'll even call it M, okay? Are there any questions? We're doing okay? Now, earlier in my other classes, I ran a full football field to talk about this. But, you know, I'm old. I'm a little tired. I guess it's going to go 50 yards, this one. Okay, so if I started at the goal line and I started my run to the 50, but I wanted to stop at the midpoint. Okay, for those people at home, I just went 5 feet and I'm tired. Okay, but say this is 25 yards, right? 25 yards. How much further do I got to go? 25 yards, because I'm at the midpoint, right? I've gone 25 yards. I've yet to go 25 yards. What if I just went 20 yards and I said that 20 yards, I'm at the midpoint? What's my other endpoint? 40. So you just took what I did in the first part and add it to the second part, right? That's what I want you thinking about for this next part, okay? Because when we're doing this next one, I've got these values here, 18 and 20, and I've got these other ones here, they're there, but this is the answer, 18 and 20, okay? And people are like, oh, I'm gonna totally get the answer. It's like, I want you to know how for every one of them. So using that example of me standing at the midpoint on the football field, whatever my endpoint would be, if I start at 4, remember, find the other endpoint. That's what I'm doing. I'm finding the other endpoint B. That's what I'm doing here, okay? They're giving me one endpoint A and the midpoint. So there's a couple ways I can do this. I'm gonna do it with you the way I do it on a test, okay? And I've written it down. You might, after you get better at this, won't need to. But if I start at 4 and go to 11, and I'm just working with X's right now. Remember, we do a horizontal midpoint and a vertical midpoint, and we're set. How far do I go when I go from 4 to 11? In what direction, positive or negative? Positive 7. Okay, so I'm going to add 7. And just like my football example, when I was on the 20, I'd already gone 20 yards, and I got 20 to go. Well, I've already gone 7, and I'm at the midpoint. So now how many do I got to go? 7 more. So I'm going to add 7 more to the 11. Okay, remember, this is just for my X value, my X's. So 11 plus 7 gives me my 18. Does that make sense? And I'm just using the idea that midpoint is manipulated by how far I've gone already. So if I start at 10, I go to 15, how far have I gone? 5. Okay. How far do I yet to go now since 15 is my midpoint? I've gone 5. I got 5 left. So I'm going to add 5. That's the direction. I'm going positive 5 because it went up. And I'm going to add 5 more, my other midpoint. And look, my original answer was going to be 1820. Okay? Are you okay with what I did? Now, I've got some naysayers out there going, I don't think that's right. Well, let's check it. Take my two endpoints, 4 plus 18, 22, divided by 2, 11. Take my two endpoints, 10 and 20, add them together, 30, divided by 2, 15. Hey, it kind of worked, okay, during the check. Let's see if it checks out algebra-wise. Because algebra-wise, if I took my first one, I would take 4 and then add x, an unknown endpoint, and divide by 2, it would get my known midpoint 11. Well, I'm going to double both sides, so I got 4 plus x equals 22. Well, if I subtract 4, x is 18. Well, gosh, that's what my x value is, my unknown endpoint. Let's see if it works for y. Same idea. I'm going to take 10 plus y divided by 2 equal 15, because that's the midpoint I'm finding. I double it, and I'm able to find 10 plus y equals 30. Well, I'm subtracting 10, y is 20. I don't care which one you do. And honestly, people prefer this method of the midpoint thing that I just did with you over the fraction, the algebra version of it. Both work, okay? But you just got to know which direction you're going, okay? So, talking about direction. If I have, and read the question, because I promise this is on the test. Both types of midpoint questions will be on the test, okay? Find the other endpoint. Notice that they want the other endpoint, A. Okay, so I've got something that represents the other endpoint, A. I don't have it yet. Okay, of AB when the midpoint of AB is negative 2, 1? Well, the midpoint of AB is negative 2, 1. They gave that to me. So let's go from 4 to negative 2. That's 6 away, and it's in the negative direction, right? I'm going to subtract 6 from 4 to go to negative 2. Well, that's my halfway of my trip. I've already done negative 6. I'm going to go negative 6 more. So negative 6 from negative 2 is going to give me a negative 8. Okay, your turn. Do Y. Hopefully, you went from 10 to 1, which is you're adding a negative 9 or subtracting 9. And since that was the first half of your trip, you're going to subtract 9 more and you're going to get another negative 8. Again, if I wanted to do algebra and find my answer, I could, because both will work. It is your preference which one you decide to do. Honestly, I would like to do that halfway trip midpoint thing because it's a little quicker. And that is the way I do it, okay, when I do midpoints. And I do check it after I'm done to make sure I've done it right, because there's always a chance for me to screw it up. Any questions from the floor about the method? Feeling pretty good? Okay, now, as we go through, we're going to review stuff. This one's Pythagorean theorem, okay? Some people go, oh yeah, dude, I got this. And other people going, dude, Pythagoras, who? Who is this humyuck? Okay, Pythagoras was a guy who came up. It's a one-hit wonder, and it's the thing that we use in geometry like every chapter. There's always a shortcut with Pythagoras. But what it comes down to is this. A and B are called legs of a right triangle. This is my right triangle. And we got C, which is the hypotenuse. C is the hypotenuse of that right triangle. C is always across from the right angle. Okay, so we have the two legs and we have C, and the two legs are always A and B. I don't care which one you put into A, which one you put into B. It's just that the legs make A and B. Okay, after you square them and add them together, you take its square root to find your C, your hypotenuse length. So in letter A, we're looking at the fact that we have 20 in for A, 21 in for B. It wouldn't matter if I put 21 in for A and 20 in for B. It's still going to end up being the same answer. Okay, 21 squared is 441, 20 squared is 400. Okay, that's 841 is equal to C squared. Do you remember the square root function on your calculator? Okay, it's a key that looks like this. Okay, and you put 841 inside and hit enter. It should return positive 29. Okay, and that is the length of C, my hypotenuse. Are there any questions about that? Because you're going to do the next two. Okay, plugging in your A and B, squaring them, adding them together, take the square root. That's pretty much the process we're going through. If you need a calculator, I got them in back. If you're at home, it's going to be a long trip to Elk River High School to get a calculator. Hopefully you got something else to use there. Okay, but just do B and C, and then we'll come back on and talk. Okay, as we're working through, they're done the same way. 6 and 8 are the legs of the right triangle. They make the right angle. So you're talking about 6 and 8 being going in for A or B. I don't care which one it would be. Because addition has a commutative property, it doesn't matter which order it is. But you have 36 plus 64 or 64 plus 36. Both become 100. And maybe perhaps I'm jumping the gun. I'm going to go 36 plus 64 is equal to C squared. So I got 100 equals C squared. Take the square root of 100 to equal C. So I got 10. Okay. Oh, okay. Questions regarding. Okay. The last one, as we're going through, I got 24 and 7. 24 squared and 7 squared. 24 squared is 576. 7 squared is 49. You add those together, you get 625. Okay, and your square root of 625 is 25. So we get the opportunity to work with integer values in the Pythagorean theorem. And all integers that work in the Pythagorean theorem, where, you know, if the A squared and B squared equals the C squared, okay, we can use the converse of Pythagorean theorem to show it's a right triangle, but these are called Pythagorean triples. Little extra thing that we're going to learn again in chapter 8, second semester. Okay. Questions regarding these, okay? You feel pretty confident with these? Now, Who's been middle named before by mom? I don't know why dad doesn't middle name, and it's always the boys that raise their hand. They're like, yeah, it was just this morning. Okay. Sometimes the girls are like, yeah, I've got brothers. I get middle named all the time. But it's when you know they're mad. You know, you're like, what did I do? I didn't do anything that I know of. Okay. Well, the Pythagorean theorem is short, you know, or the distance formula, I should say, is short for the Pythagorean theorem distance formula. It's all based on the Pythagorean theorem. This is the Pythagorean theorem up top here. Okay. If I follow through with the length of my horizontal length, x sub 2 minus x sub 1, two different x's, and my vertical length, y sub 2 minus y sub 1, and I plug them in for a and b because they're legs of a right triangle, and square them because according to the Pythagorean theorem, and then at the end, I take the square root on both sides, what results is the distance formula. That is the derivation of the distance formula. That's where it's from. Okay. People go, oh, just make this junk up. No, it's actually there. It's a proof of it. And this thing's so important. I'm actually doing it today in my pre-calc class. Okay. We're doing absolute value, distance formula, midpoint formula, and Pythagorean theorem. Okay. Same stuff I did with you guys because they have to be reminded of it. Okay. Now, this is the formula we're about to use. Okay, and it's the same formula I'm going to have on the problem. So there are some people here, it's the same formula at the top of the page right there. Okay, again, just like midpoint, we have x's and y's, except we're working with differences instead of adding. The x's are the first value in a coordinate pair, the y's are the second. Make sure you know that. And I've even delineated x sub 1, y sub 1 in this first coordinate pair in A, and x sub 2, y sub 2 in the second one. So you know you can just plug them in. So plug them in. We're using the distance formula. This is the distance between 2 points in the Cartesian coordinate plane or the xy coordinate axis. Okay. After you plug them in, you evaluate according to the order of operations. 7 minus 14 is negative 7. Negative 4 minus 20 is negative 24. I've got those squared. After I square them and add them together, my final answer should be larger than the individual squared answers separately. And that I say it that way because a lot of people make mistakes with their calculator and they go negative 7 squared and come up with negative 49, or negative 24 squared and come up with negative 576. And folks, if we're squaring them right, they should always be positive numbers. Okay, so when we add two positive numbers, we should get a larger positive number as we go through. So we should get 49 plus 576. And right now you should be going, gosh, we just did this above in problem C. Same problem. I just had you start with coordinates instead of just the side lengths. The coordinates, finding those that subtract, gives you that one value for the side lengths. Okay, and that's where those are from. So now I can just finish this off and say it's the square root of 625, which is just 25. So my length between A and B, and that's what that is, AB. People go, what's ab Bloom? Okay, and it's not a workout, okay? It is the distance between A and B, all right? When two capital letters are mushed together like that, they're descriptive variables. The distance between A and B is 25. So what I'd like you guys to do is do number 6. It's done in an identical manner. Take those over. You can even take these over, okay? Because we're doing the same thing. Go, plug in your values, evaluate. Okay, probably some of you folks at home noticed the same stuff the people here on campus noticed. When we're doing this, I had an x sub 1, y sub 1, x sub 2, y sub 2. Somebody said, boom, you put that x sub 1 in the x sub 2 spot and the y sub 1 in the y sub 2 spot. It doesn't matter. And the thing that's a great equalizer with that is squaring it. Because when I subtract, order matters, right? If I take 5 minus 2, it's 3. If I take 3 minus 5, excuse me, 2 minus 5, it's negative 3. But if I square negative 3, or if I square 3, they're both 9. So the order matters all the way up until I square it. Once I square it, I can make the mistake of the order. So what I did in the first one, I'm going to reverse. I'm going to say, hey, well, I'm going to do 11 minus a negative 2 squared plus 19 minus a negative 1 squared. Okay, and it would still be the same as if, now remember, I'm gonna kind of put a little bubble in here. Okay, if I wrote the other way and I went negative 2 minus 11 and negative 1 minus 19. In this one, the second one I drew or wrote out, this is negative 13. Okay, maybe perhaps we'll make it neater. This is negative 13 squared. Well, that's 169. This is negative 20 squared, which is 400. Well, what's 11 minus the negative 2? Well, that's 13 squared. Still 169. And 19 minus a negative 1, which is plus 1, is 20 squared, which is 400. So both of them are still coming up with the square root of 576. Excuse me, I don't know where 576 came from. 569 is better if we actually do this right. And that's going to be 23.85, was it? Okay, feeling pretty good with that? Okay, so the order matters to a point just to make sure you treat if you pick one of your points as the second, the second subscript, be consistent, use that always as the second. Pick one of them as the first, be consistent, use that always as the first. Subscripts are there to tell the user of the formula in the equation, you need 2 different points. Okay, that's a communication thing. We don't have to write it on the side because we say it in the formula itself. Okay, now we got 5 and 6 done. Let's go after 7 and 8 and see how you do. Okay, do it on your own. I guarantee the more efficient you are on this, the easier these become, and the easier it will be when you do them on the test and quiz. Yes, I said that. They're on the test, they're on the quiz. Hey, it was asked in class why we're not doing section 1.6. 1.6 isn't going to be tested on chapter 1. The 1.6 section was omitted in lieu of our college fair day that's going to happen on Friday next week, and our chapter 1 test is on Thursday because of that, not on Friday. So, and I deleted that 1.6 section, so we're not going to do it on the college fair day. We're not going to do it so we can get that test in. Going back to 7, let's check out our solutions, and hopefully you got 5.39. Okay, notice that I'm being more brief about the information I'm showing. I just want to make sure you know what numbers I put in, my totals, and how I got to 29. And notice 29 is bigger than 25 and 4 separately. So pay attention to that. At this point, I shouldn't have negative values at all. Okay, and then the last one, popping it in, getting it done, I should come up with 4.24. And notice that one's even briefer than the previous ones, because as we get better with these, we're more familiar with where X's and Y's go. Yes, sir? Well, this becomes 2, because this is -1 plus 3. So that's where 2 and it's 2 squared. But thank you for pointing it out, because those type of mistakes I do make, and I apologize in the future already. Okay, but whew, made it through on that one. Are there any other questions? Okay, fantastic. That's notes. Okay, and we have the assignment. It's on Schoology, but I'll list it out. It's 1.7, page 54, numbers 7 through 45 odd, 46 to 51, 53, and 55. Thanks for your time, folks.